Now in probability, you have binomial distribution probability. Now, before we start, it's important to understand that formula. As we see it at first glimpse, you may be scared, but don't be. We will explain what it is. So n represents here the number of time a process is replicated. So that's why we call it probability of success. So how many times has it been done? And P obviously represent probability of success, and X here is the number of successes of interest. And as we do examples, we'll clearly expound. Now there is that exclamation point right there, and you may be wondering what it means. It means factorial. Now if you've taken probability in the past, factorial just means that we're multiplying the number in a decreasing order. For example, if we have 2 factorial, then it means 2 times 1. If we have 5 factorial, it means 5 times 4 times 3 times 2 times 1. Here's an example of a binomial distribution. Medication for cold and flu is effective in reducing symptoms in 80% of patients. If medication is given to 10 patients, what is the probability it is effective in 7? So here, it's important that we know what we've been given. So here, looking at the formula from last slide, Px successes here, the successes here are 7. So X here is 7. And N here, which is the number of time is being replicated, we have 10 patients. So it's been given to 10 patients. So here N will represent 10. Now we're still missing 1. We're still missing P. Now P is P here, which is the success itself, represent 80%. Now in decimals, which will be 0.8. And that is it. All you have to do now is put the numbers in the formula. And remember, the exclamation point represents factorial, which means in this case 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Also, you could use your calculator and plug it in, and you should get the response that we have there. In this example, antibiotic is claimed to be effective in 7% of the patients it is given to. If antibiotics is given to 5 patients, what is the probability it is effective on exactly 3? Now it's a little bit more specific. So the success, which is antibiotic, is effective. N equals 5, because there are 5 patients being replicated 5 times there. And P here, which is 70%, 0.7. And X, number of successes, and because we said it was 3. And then we plug in the variables to get the values to get the number. In this exercise, what is the probability that the antibiotic is effective on all 5? That would be from the previous slide. Here, the only thing that changes here is X. Now we're not looking for exactly 3 successes. Now we're looking for all 5. So that's the only thing that changes here. The concept remains the same. In this case, following the same problem, what is the probability that the antibiotic is effective on at least 3? Every time you hear at least in biostat, it means 3 or more. So in total here in the problem, if we look back in the other slide, we see that the total number of patients equals 5. Correct? So if the total number of patients is 5 patients that were given the antibiotic, then probability of X greater or equal to 3, because it says effect on at least 3, so every time you hear it, it's greater or equal to the number that you've been given, which would be probability of 3 plus probability of 4 plus probability of 5 successes. The same problem could be answered differently. as we see in this slide, the probability that antibiotic is effective on at least 3. Here, which is again 3 or more, so probability of X greater or equal to 3 can also equal to, remember probability goes from 0 to 1, equal to 1 minus the probability of X less than 3. Probably X less than 3, which will be 0, 1, and 2. So you could also do it this way. 1 minus the sum of the probabilities of 0 plus 1 and plus 2. Sometimes, depending on the values you were given, you may have to revert to this method.